Okay, so today we're just going to be looking at the exponential graphs and tables. There are certain things that you need to be able to recognize on those. Yesterday we talked about the parts of the equation. Now we said that the equation for an exponential function is y is equal to a times b to the power of x. You know where to get them. So written in this form, just know a cannot be 0. Why? Because the numbers are multiplied, and if I multiply by 0, what happens to my equation? It cancels out. B has to be a number greater than 1. And also B cannot be, we'll talk about y has to be greater than 1, and then we'll also, B cannot be 0. Once again, if I put a 0 in this spot, then it'll cancel, or it'll make the whole equation 0, which will...
It will explode.
It will explode, whatever. The graph of an exponential function increases or decreases rapidly. What words did we use for the increase and decrease? Growth and decay. Now, an exponential function, or an exponential graph will always in Algebra 1, it will always have a horizontal. This is a brand new vocabulary word. Asymptote. It's pronounced without silent P. Asymptote. Okay? Asymptote. And we're going to take a look at what that is in a little bit. All right. I'll come back to this. So let's look at our graph here. Why did it minimize? Oh, yay. Now I gotta type it in again.
What is equal to 2A H 2 B X.
All right. Now we said that A cannot be 0 because if it's 0, what happens to the graph? What happens to your exponential function? It goes straight. It becomes a straight line. Let me see.
It died.
Okay. And then B has to be a number. B cannot also be a 1. Because if it's a 1, what happens to the graph once again? It goes straight. So it either has to be greater than 1 or less than 1. We said if it's less than 1, decay, it decreases. If it's greater than 1, it increases growth. Yes? Okay. So I'm just going to make it a 2. Now, look at the graph. What do you think is the x-intercept? What does it look like the x-intercept is? What do y'all think is, give me a number for the x-intercept. No. Give me an actual number. One that's on the graph. Okay, so some people say it looks like it's crossing at the -4 or it's touching at the -4. But if I zoom in, what happens? It's not. So then that makes my x-intercept what? Okay. Well, if I zoom in on the -6, what happens? Not touching. So that means it has to be what? -10?
Yeah.
So think about whenever, have you ever tried to put two magnets together? Yeah. It's kind of like that. There's a reason why it won't touch the The x-axis is because of that asymptote. What is the asymptote? Let's look at that definition. It says the asymptote is a value that your graph approaches when it gets very large or very small, but it can be thought of as an imaginary boundary line. So think about whenever you're trying to connect or trying to hold two magnets together and they kind of just slide back and forth. They don't actually connect. That is what your asymptote does. It prevents the graph from actually touching the x-axis. So since it never touches the x-axis, there is no x-intercept. It can go all the way to negative infinity and it's still not going to touch. It will never touch the x-axis. Okay? So for exponential functions, you will never have an x-intercept. At least not in Algebra 1. Okay? Now, we talked about the parts of the equation yesterday. So what is the initial value? How do you know it's 1? You can actually find it in a few different spots. How do you know it's 1? Okay, so if you look at the y-intercept on the graph, the y-intercept is 1. We know that the initial value and the y-intercept are the same thing, okay? So I can go ahead and write that my y-intercept is 0, 1, okay? Where else do you see that?
The chart on the top.
Okay, if you look at your table, your y-intercept is written in there. Where else do I see it? Or where else do I not see it? Where else should it be? The equation. Where is it located on the equation?
Nowhere.
The number in front of the parentheses. If there's no number in front of the parentheses, that automatically tells us that my number is what? 1. Okay? Now, my factor. Is that factor greater or less than 1? How do you know it's greater? Because the line's going up from left to right. Okay. What else? My factor is what, Jonathan? My factor is 2. This is where my factor is located. And if my factor is 2, I know I'm going to see what? Growth. You can also tell one more different way. You look at your y values. Look at your y values. So your y's are increasing. Overall, your y values are increasing overall. So that should tell you that your factor is greater than 1, that b will be greater than 1. Even if you don't know what the factor is, even if you don't know what number you are multiplying, remember your factor is a multiple. Even if you don't know what number you're multiplying by, you know that the numbers are increasing, so my b has to be greater than 1. But you are in algebra, so what number are we multiplying by to increase? We're multiplying by 1? We're doubling. We're multiplying by 2 every time. 1 times 2 is 2. 2 times 2 is 4 times 2 is 8 times 2 is 16. So you are able to recognize that it is multiplying by 2 every time. Okay? Let's look at the second graph or the second equation. What's my initial value? All right, where do you see that?
On the graph.
There's no number in front of in the very beginning of the equation. Where else?
On the chart, because 0, 1.
Okay, we have our y-intercept literally on the table at 0, 1. Where else? And then where?
The graph.
On the graph. Your y-intercept is visible on the graph. Okay? What kind of factor is my b going to be greater or less than 1?
Less.
How do you know?
It's half.
Okay, well, Jonathan went straight to the equation. Where else can you see, or how else can you recognize that the factor is less than 1?
Decreasing on the chart.
Okay, so your exponential graph is going down from left to right. If it goes down, that means we are what? Decreasing, decaying. Look at your y values.
They're going down as well.
Your y values are going down. We're decreasing. We're decaying. And that's 6. This is a typo. This 6 should actually be an 8.
I knew it.
Sorry. Why didn't you say anything?
Because I didn't feel like it.
Ugh. All right. Flip it over. All right. This time I did not give you the initial value in the equation. You got to tell me what it is.
4.
How do you know?
0, 4.
Correct. You see it on the table.
I'm so
0, 4. You see it in the graph. All right, is this growth or decay? Is it be greater
Growth.
or less than 1?
Growth.
How do you know it's greater than 1?
3 over 2 simplifies to 1.5.
3 over 2 simplifies to 1.5. 1.5 is greater than 1. What else?
It's raising. It's going up on the chart. I mean, on the graph.
My y values are increasing. My line is going up from left to right.
Oh, my pencil.
Okay.
Why did my pencil suddenly jump off my desk and start flying?
Because it felt like it. All right. Last one. Oh, wait. Go ahead and fill in your 4. Ready? Last one. What's my initial value?
3.
3. Where do you see that?
The chart and the graph.
You can find it in the table. It's labeled on the graph. All right. So as as an ordered pair, we write it that as y3. Is my value greater or less than 1?
Less.
How do you know it's less?
It is 1.8.
It's dying.
My factor is 0.8. What else? How else do we know we're decaying?
Because it's going down. Your y-
The
your y's
exponential
are-
function is going down. How else do we know?
Your y's are decreasing.
Your y's are decreasing. Your y values are decreasing. Questions? All right, that's it.